Part 5. Other bases. Base 10 is not the only base used in logarithms. Base b may be any number. As in an earlier example, 4 to the x equals 9, where the base is 4. That equation was solved for x using the log power rule. What was done there to find a solution was to change 4 to the x into 10 to a log. You have already learned about base 10. The two other most prevalently used bases in logarithms are base e and base 2. Base 2 is used in computer programming. Base e is used in science and finance. The logarithm values for base e are programmed into calculators. Log is a general abbreviation that is assumed to refer to base 10 unless otherwise specified by a subscript. The log, base 10, of a number is called the common log, and its function is abbreviated Lg when it needs to be differentiated from other bases. The log, base e, of a number is called the natural log, and its function is abbreviated Ln. The log, base 2, of a number is called the binary log, and its function is abbreviated Lb. When writing functions Lg, Ln, or Lb, we need not write the base subscript, because it is understood as being incorporated into the abbreviation. We will now focus on base e. The topic of what e is a separate subject unto itself. For now, suffice it to say that e approximately equals 2.7183, and that it is a number that describes certain rates of growth. It is one of the so-called magic numbers, like pi and phi. E, when used as a base, as we have used 10 so far, possesses a set of logarithms that was worked out by mathematicians and is now programmed into modern calculators. These are the natural logarithms. You were introduced to this equation when you were learning base 10 logarithms. We let b equal 10. Now we are making the generic term b equal to e 2.7183 and writing it like this. E, when used as a base, as we have used 10 so far, possesses a set of logarithms that was worked out by mathematicians and that is programmed into modern calculators. These are called the natural logarithms. Now you will be shown the special terminology for expressing functions involving e. Whereas for the base 10 common logarithm, we had these. L equals log base 10 of a, in other words, L equals the Lg of a, and a equals antilog base 10 of L equals 10 to the L, in other words, a equals the Lg minus 1 of L equals 10 to the L, which is just an exponential and an exponential function. Now, for base e logarithms, we have L equals log base e of a, or L equals ln of a, and a equals antilog base e of L equals e to the L, or a equals the exp of L equals e to the L. The antilogarithm function for base e isn't just any antilogarithm function. It is the exp of L, and the antilogarithm formula, e to the L, isn't just any exponential. It is the exponential. Rewriting it all more succinctly, let's plug e to the L in wherever a was. And we have these two core equations. Most explanations of logarithms use the word and its abbreviations, LG and LN, to refer both to the functions and the values. I find this confusing. That is why I invariably specify whether I am talking about a value or a function. This distinction matters when you encounter functions nested within an exponent. Now, on your calculator, practice finding the natural logarithm values for the following numbers, using the ln function. Press the ln button, and then the number you want the natural log value for. Then press the equals button. Pause the video. Here are the answers. Each of these natural logarithms is the power to which e must be raised in order to obtain the number in question. For each example, you just performed this operation. You found the value of L, the natural logarithm, by using the ln function on your calculator. And the term you did it to was the anti-logarithm, which equals e to the L. So, now do the reverse of what you did just previously, and find the value of the exponential for the following numbers, which are natural logarithm values, by raising e to L, the value of the natural logarithm. On your calculator, press the e to the x button, then the natural log value, then the equals button. If your calculator doesn't have that button, press e, then press the x to the y button, then enter the L value, then press enter. The answers are the numbers you began with for the previous exercise. Here are their names. And here are the functions that produce those numbers. Do you see how logarithm functions and anti-logarithm functions undo one another? Practice rewriting the log rules you have learned so far, using E notation. The next video will be about base switching.